Okay guys, this is going to be a quick lesson on solids, liquids and gases. Now you've actually learned about this in primary school and grade 7, but we're trying to get you to think of it a little bit more deeply now that you're getting into high school. So when we talk about solids and liquids and gases, we're talking about matter. Now you may not realize it, but everywhere around you is matter, and I do mean everywhere. Matter is what has mass. It's the stuff that makes up everything around us, whether it's the liquids that we drink, whether it's the gas that we breathe in, whether it's the solids that we stand and sit on or wear, our clothing, even our bodies are solid in the muscle tissue that you have, they're liquid in the blood and the water that's in our cells, and we even have gas inside us in our lungs. So we have all different states of matter even in our own bodies. So everything around us is made up of matter in different states. The only place you don't find matter is in the vacuum of space, or in vacuum, if you've heard that word there, vacuum. Okay, in thermoflasks where you have areas of vacuum where they've sucked the matter out. That's to do with stopping heat transfer, but we'll talk about that a little bit more in grade 9. Now back to solids, liquids and gases. What you have to remember here is this. Solids, liquids and gases are the same thing. Anything can actually exist as a solid, liquid or gas. It just depends on how much energy it has. So let's have a look at solids to begin with. Now here we've got some solids. Now when solids have very little energy, the atoms or particles that make them up are stacked really closely together and they can't move much. They're only moving just a tad, vibrating around, but notice that they're not moving anywhere around the place, and because of that they hold their shape because they can't move around, and that's a very low energy form of matter. When it doesn't have a lot of energy, it can't move around, it has to exist as a solid. But as you know, any solid can be heated up. Think about tin roofs on your roof. When they heat up in the daytime, you'll hear them creaking. And that's because those particles are being heated up and given some more energy. And although they're not melting yet, they're certainly vibrating an awful lot more than they were in their cold state. And because of that, they knock and push at each other and push each other apart. And so as you give them energy, they expand because they push each other apart. So that's solids for you. Now, if you give that solid just a little bit more energy, it will actually break free of its solid state. So this one here, he's been given so much energy, he breaks free and he starts to melt or pull apart from the other solids around him, and they become liquid particles. So this is the same atoms or particles that we're talking about, but this time they've been given so much energy that they can break free of each other and start to move around as liquids. And that's what we have happening here. So say this is your metal tin roof. If it got heated up so much that the metal in that roof started to melt, this is what it would look like. Now those particles there are moving around slowly. They're no longer holding their shape because they can move in all directions. So they don't hold their shape. The only way you can make them stay in a particular shape is now to put them in a container. So they're contained within that container. Now liquids as well as solids will expand if you heat them up just a bit. So if you heat these guys up, if you give them more energy, then they will start vibrating even more and getting very close to the point where they start to boil almost. So they will actually heat up and expand, and as you can see here, they're going a lot faster than they were before because we've given them more energy to move. And this is what hot liquids would look like compared to the cold ones down here. They move and vibrate a lot faster. So they will expand themselves as you give them more energy. Now the next thing is gas. Now if you give them just a tad more energy, and they'll actually be able to go out of their container, as you've seen gases do, and go all different ways because they have enough energy to be a gas. Now gases are essentially just liquids. They've been given enough energy to break free of their liquid form and turn into a gas. And this is what gases look like. So all you've done when you go through each state, you've got exactly the same piece of matter. It could be water, it could be metal. But as you heat it up and you give it energy, it will start to expand. And if it gets enough energy, it will then transform from one state to another. Okay? So that's the big picture of solids, liquids, and gases. Okay, so a few things to remember. As you go up from solid to liquid to gas, you do so because you gain energy. The other thing is, apart from water, as you go from solid, liquid to gas, you also expand the distance between your particles. Now the reason these guys are expanding is because all particles have a certain amount of attraction to each other. It means that as long as they don't have a lot of energy, they will actually pull to each other, and it helps to hold matter together. But if you give matter enough energy, it will actually break free of these connections, and the particles will go in whatever direction they wish. You just need to give them enough energy to overcome that cohesive force that is between those particles. And of course you get expansion as you go. So the key things you need to remember: solids, liquids, and gases. As you move up, they expand. In other words, the distance between the particles increases. This is because they have more energy. And when you give them energy, they start to move and vibrate more. And as you do so, first of all, they will expand. Then they will actually transition from one state to another. In this case, it's going from solid to liquid. And when something goes from a solid to liquid, they actually have a word for that. It's called melting. Then you will have liquid. If you get enough energy, it will then transition from liquid to gas. That is called evaporation. And the opposite happens when you go back the other way. If you suck energy out of particles, if you take their energy away, you're cooling them down. That will actually force them to slow down, vibrate less, and go back through the states the other way. So if you cool gas down enough, it will actually turn back into a liquid. This is called condensing. And if you cool down liquid enough, as you know, it will turn back into a solid. This is called freezing or solidification. Now there is one thing, there are some solids that will actually go straight up to their gas form. They actually skip the liquid form entirely. This is called sublimation, and it's in your textbook. Alright, good luck with that, guys. Off you go.